Okay, continuing on with stream dynamics, let's look at erosion and deposition. Two things that happen over the course of the life of the stream. You're either eroding and then eventually you carry that material and you deposit that. Now, one of the main factors of this is what we call the stream discharge, the volume of water moving past a point in a given unit of time. And you figured this out very simply. Q is the stream discharge, W is the width, D is the depth, V is the velocity. So you multiply these three together and you get generally either cubic feet per second or cubic meters per second. And notice the important thing is if you change any one of these three, you change this. If it becomes wider, the discharge gets greater. If you make it deeper, discharge gets greater. If you make it faster, discharge is greater. If you make these less, then the discharge becomes less. Okay, so that's why this is so important. And it's directly relatable to the erosion of the stream bed and the deposition, the depositing materials as the stream moves further downstream. So there's your depth, your width, and the velocity. So multiply those together, and so the area is width times depth times velocity. That will give you some measurement, whether it's feet or meters in cubic feet or cubic meters, and that'll give you the discharge. This isn't going to be on the test per se, but it's important to know in your mind's eye so you can get some idea of what it means when we talk about the discharge of various rivers. And so notice here, 4 meters by 1 meter, so the area is 4. The velocity is 3. 3 times 4 is 12, so it's 12 cubic meters per second. That's the discharge. So here are the rivers with the greatest discharge: Amazon, the Congo, and the Changjiang or the Yangtze in China. In North America, the greatest discharge is the Missouri, Ohio, Mississippi river system. And so that's kind of what it looks like. So notice here that the Nile is the longest river by far, but it's very low. It's only 36 in the discharge, only 100 cubic feet per second, that's because it's such an old river. It's worked its way down to its base level. On the other hand, the Amazon, it's the second longest, but notice its discharge, 6,300 cubic feet per second. So almost, 6 times greater, 60 times greater than the Nile. And here's the Missouri, so it's only 650. Basically the Amazon is 10 times, the discharge of the Amazon is 10 times greater than that of the Mississippi. And that just kind of, in the most flow again, this is looking at January. So there's the Amazon, there's the Mississippi, here's the Congo, which is number 2, and then the Yangtze, which is number 3. So this gives you some idea where they are and the amount of the most flow, which is generally in January. So there's the mouth of the Amazon. Here's this would be, north would be this way, so we're looking kind of to the east. Notice all this discharge. You can see all this sediment that's being deposited, that came from way up in the Andes Mountains. And again, mixed with all that rain, a lot of erosional material. And it's over time, this is, again, it's its own ecosystem, this kind of mixture of salt water and fresh water. It's developed into its own unique ecosystem. Just another view of it. You see how green it is, but again, all this sediment load being brought down from the interior of Brazil. Here's the Congo River, flows through the center of Africa. Again, it's a rainforest environment. And right here, this is kind of a basin, and then right here it goes real dramatic waterfalls right here. as it goes down. That's why it was so difficult to get into the interior, because you had to portage your craft over these waterfalls to get to the river itself, which is fairly slow moving. And here's the Yangtze River. And again, they have dammed this up, started in 1987 and finished it in around 2006, 2007. This was the Three Gorges Dam. So it looked like that, and now it looks like this. You know, displaced millions of people. It was kind of a human rights crisis where you forced all the people that used to live and farm here, you know, they were agricultural, economic, and forced them to move into the urban areas. Okay, so that's erosion and deposition. So then we'll move on to stream types quickly in the next part.